All right, I'm going to start that recording. I'm going to start this recording. Yes, I'd like to record this session. What's going on, folks? Let me just say that you folks are awesome. I think you folks are an awesome batch of students. All right, I finished grading as much as I could. I hope that the homework assignments have been straightforward to you. I was a little bit relaxed with grading with grading those first two labs, because I understand this is your first time doing it, so maybe I was a little bit more chillaxed about it, and so I gave you folks a lot of points. What I want you to do is I want you to check it out, because some of you accidentally submitted me didn't submit it correctly. And so I want to make sure you guys submit it correctly. So I'll probably be calling you sometime later on tomorrow if you didn't submit your assignment or you didn't submit it correctly. What I want to do today is, all right, the schedule says that we're going to go from 10:30 to 11:55. Let me tell you something nice. Instead of going for an hour and a half, I'm only going to go from 10:30 to 11:15. That's 45 minutes. The reason being is because I have on the schedule 10:30 to 11:55. That's when I want to finish. However, what I really only want to reserve that time, that hour and a half block, for when we're doing lab, when we're actually here doing lab. When it's a regular lecture day, I don't feel like I need to speak to you guys for a whole hour and a half. I think that your brains are going to fall off if Mr. Dalday just straight up lectures for an hour and a half. Fair enough? So that means on most Wednesdays when we don't have a lab, even though you see in the schedule the class goes from 10:30 to 11:55, that doesn't mean that it goes actually from 10:30 to 11:55. All it means is we will probably be going from like 10:30 to 11:15. Although I do reserve the right to be able to take that extra time if I wanted to. Like if we're really deep into a subject and we're talking about it and all of that kind of stuff, I will say, hey, we're going a little bit late, and you know what? That's my prerogative. So I get to block out that amount of time out of your week, and I get to choose whether or not I'm going to use it. And I'm going to tell you right now that I probably will try to keep away from talking your head off for an hour and a half. All right, your brains are already shredded. Well, today we're going to do some more shredding of your brains. What I'd like to do today is I'm going to finish up the scientific method. And then after we talk about the scientific method, and we talked a little bit about that Clever Hans one, I want to start talking about water content. Let me ask you this. In the book, did you folks hit the part where they talked about a double blind test? Okay, cool. So when you guys hit that part, you guys knew what was going on, right? Now, I read the book about like half a year ago, so I can barely remember it. But let me think. I think it was where Lei was doing a double blind test. Oh no, she was asking the doctor. She goes, well, did I get the pills? Did I get the right pills? I'd like to know. And then because she's assuming that it's a blind test where she doesn't know whether or not she got the placebo pill, which is the pill that is like really just made of candy, and it doesn't taste like anything. It's just a pill that doesn't really work. Or did she get the real stuff? Right? That's where Leigh wants to know. And then she asks the doctor, and so the doctor says, "Well, I'm sorry. I wish I could tell you, but the thing is, it's a double blind test, so even I don't know." But the double blind test, I think that, didn't you say something like, but based on how well you started doing, but based on how well you are, you started, or you've been progressing in this thing, you probably started receiving the drug and not just the placebo. Anyway, so we talked about a hypothesis. We talked about an experiment. In an experiment, and this is the part I really graded you on inside of your experiments. What are the things you need to control? That is super important. What we want to do is you have the dependent variable and the independent variable. Let me ask you this. Which one is the dependent variable? Tell me in your words. A little more words than that, please. What is the dependent variable? Unless none of you don't know, and then if you don't know, say IDK. At least talk to me so I know that you're alive. Okay. All right, I got a high IDK. Hold on. I got a bunch of hold on. I appreciate that you let me know that I'm alive. Okay. Come on, folks. The dependent variable. All right, fine, I'll tell you. Even though you asked me to hold on. All right, I'll hold on for like 10 more seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, the dependent variable is usually the thing that you measure in the end. Like, for example, that sweater lab that we did. It's the thing that we're measuring the temperature in the end. Does that make sense? Or if I wanted to make a test on certain foods makes my dog poop a lot. The amount of poop that the dog has in the end is the dependent variable, because the number of poop that the dog has in the end depends on what type of food we feed it, right? So, the volume of poop measured in milliliters or whatever it is will vary depending on it. It depends on the food you feed it, or something like that. I don't know. I just made up that experiment off the top of my head. So, since it depends on something else, that's the dependent variable, which actually even points to us the independent variable. The independent variable is what you want to change. It's kind of the thing that you're going to experiment on. For this made-up experiment, we changed the type of food that we feed the dog. Maybe a more acidic food makes the dog poop a lot or something like that. So you would trade out foods depending on their acidity. And that doesn't depend on anything. You decide to change that thing. It doesn't depend on something else. You see what I mean? That's the thing you're trying to test. So the dependent variable is the thing that is the result that you measure. The independent variable is the thing that you change. And everything else is a control. An experiment only can have one independent variable. For example, if you want to measure how much your dog poops or something like that, and what you want to do is you want to test maybe the acidity, with one meal feed him certain kind of food, and then another meal feed him a certain kind of food with a latte and a diarrhea pill and all these different things. Don't change all of the variables, because what happens then is you're messing with your control. So you only want one independent variable. With that sweater experiment, which is a lot less gross than the one I've been describing, so I'm going to jump back to that one. With the sweater experiment, all you're changing is the color of the sweater. You're not changing the type of the sweater or the length of the sweater or the time that you do the experiment. You're changing the color. You're changing one thing. That's important. So your independent variable is the color of the sweater. The dependent variable is the temperature depends on the color of the sweater. Or the amount of poop depends on the acidity of the food, or something like that. Does that make sense? It's important that you guys are able to identify those. All right, controls, control group, control experiments. These are very important. We went over this. The results that you get need to fit your data. So even if your data doesn't make sense, you need to conclude results that is based on what you actually did measure, not what you wanted to measure. That would be messing with the results. All right. Conclusions need to be based on your results. What you'll do is you'll go back to your original hypothesis and say, well, this is what I originally thought, and this is what actually happened, and so I'm going to accept my hypothesis or reject it, depending on whether or not it worked. And we talked about Clever Hans and the double blind experiment, and I'm going to probably do something on that with you. But before I do that, I'd like to go over some of these slides. And it's a SpongeBob thing. Do you like SpongeBob? Is that kind of a thing with you guys? The old one? Wait, is there a new SpongeBob? Are you talking about the movie SpongeBob? Because that was kind of horrible.
Cartoon series?
All right. I don't know. I tried coming up with like a character that appealed to kids. So I figured I'd try SpongeBob because I mean, you probably watched that when you were a kid or anything. You know, like for me, it'd probably be like I don't know, Reading Rainbow or something like that. That was cool back for me. Anyway, I'm sorry that so much of you hate SpongeBob. I apologize for making SpongeBob, but I guess what? I made the examples all SpongeBob, and I made a quiz out of SpongeBob. So deal with it because I thought you liked it. I was trying to help you. All right. Well, it's all right. You don't need to know anything about SpongeBob to actually do well on this quiz. All right. Example one: SpongeBob loves to garden and wants to grow a lot of pink flowers for his pal Sandy. I kind of think, and I'll be honest with you, I haven't watched much SpongeBob in my time because it was I was like in college by the time the SpongeBob came out. But I kind of think that SpongeBob has a crush on the squirrel. Is that correct? I don't know. You folks are the experts, not me. He bought a special flower power fertilizer. Seamus, be careful with what you're saying. I know you're saying just, random characters, but, you know, be careful with that. All right. SpongeBob. All right, let's just change the words. SpongeBob likes the squirrel. He bought a special flower power fertilizer to see or if it helps produce more flowers. He plants 2 of the same size in separate containers with the same amount of potting soil, and he places one plant in a sunny window and waters it every day and in fertilized water. He places the other plant in a shelf in a closet and waters it with plain water. What did SpongeBob do wrong with his experiment? I'm going to go back. There's my question. He put 1 pot of water in. All right, you know what? I'll tell you what. I need to change this presentation because I realize this is. 1 second. Give me a second. I'm giving you the answers right when I'm giving you the question. So let's not do that. All right, here we go. All right, let's close this thing. We will scroll down here. Go to experiment 1. Huh, why did I get signed out? Can you folks still see my computer screen? All right, 1 second. Okay. Can you see that? Is that too small? Let me make it bigger. How's that? Is that better? You got to look at the computer screen. What do you mean you don't see anything? It's been the computer screen, this whole same computer screen all along. All right, there we go. Tried making it bigger. All right, here we go. Is that better? Can you see that a little bit better? All right. How much longer is it done? Am I really that boring to hang out with that you're like, oh man, just finish already. I hate you. All right, here's my question. Before you start thinking about how much you hate me, what I'd like to know is, what did SpongeBob do wrong? Wait, no, I don't care how cool I am. What I want to know is what he did wrong. He placed one by the window. He put 1 plant out in the sun. What's wrong with doing that? And on the shelf. Oh, I see. So his problem was, there we go. He put 1 in different sunlight. So he's testing 1, and he's testing the other but one of them he put it in two different places. So not only is he changing the independent variable, in this case the independent variable is the fertilizer, right? And so what he's doing is he's changing the independent variable by giving one fertilizer and one not fertilizer, but he's also changing the controls where he's giving one more sun and one less sun, and one yeah, that's basically it. One's got a lot of sun and the other one's in a closet. That's what's broken with his experiment. Got it. I see. Okay, good. What can he do to test the effectiveness of his fertilizer? How can he design it correctly? And while you're doing that, I'm going to finish off the rest of these slides to fix them. All right, come on. I want you folks to type it up. I'm waiting for your answer. Give me a second. There we go. All right. What did you say? All right, here we go. He should have placed them both in the same place. I agree. Yes. He should have placed them both in the same place, and not only that, he should water one with fertilizer and water one with regular water. And then if the one with fertilizer grows bigger or faster or whatever, more pink, I don't know, whatever he wants the result to be, if it grows, let's say taller, then he knows, then he can conclude that the one with fertilizer actually worked. But what happens if they both grow taller and they both grow to the same height? Gabriel, I'm going to ask you to turn off your computer, your camera. Thanks, dude. All right. What happens if they both grow to the same height? What does he have to conclude? That the fertilizer probably didn't affect the plants. Cool. All right, now I have the discussion on that, but basically it's so small that you can't see it. All right, here we go. Let's do number 2. Patrick loves bubble gum. He would like to be able to blow bigger bubbles than anyone else at Bikini Bottom. To prepare his Bikini Bottom Big Bubble Contest, he bought 5 different brands of bubble gum and needs your help to find the brand that creates the best bubbles. Write an experiment to test the bubble power and the bubble gum brands to help Patrick win the contest. No, my webcam isn't up. I don't feel like you need to see my pretty face. It's not that much motivation. All right. You know what? I'll tell you what. Let's skip this one. I don't want to write up a whole experiment in an example problem. Let's try the next one. SpongeBob has noticed his pal Gary. Now, which one's Gary? Is that the squid? I don't remember. Oh, it's the that's his dog, right? Anyway, it's weird. Yeah. It's his pet. Like a pet snail, but he treats it like a cat or a dog. Anyway. SpongeBob. Gabriel. Dude. We love your face. Actually, you know what? I don't mind. It's cool. You can keep your webcam up. Just don't be doing obscene gestures, all right? Deal? Got it. All right, Gabriel, you keep your webcam up. Don't turn on your microphone. That I won't allow. Okay. SpongeBob notices his snail is suffering from slimatosis. I suppose that would make sense since it's a snail, which occurs on the shell when the shell develops a slime and gives off a horrible odor. Stinky shell, huh? His friend Patrick tells him rubbing seaweed on the shell is perfect cure, while Sandy says drinking Dr. Kelp is a better cure. SpongeBob decides to test this cure by rubbing Gary with seaweed for 1 week and then having him drink Dr. Kelp for another week. After a week of treatment, the slime is gone, and a week... what? Oh, after a week of treatment, the slime is gone, and Gary's smell is better. What was the initial observation? What was the thing that caused the question? That's my question, dude. Yeah, yeah. Gary is smelly. I love it. I love it. It's he initially observed a gray slime uh, that is well, not it's not Gary. Yeah, Gary's slimatosis. That's what the initial observation. In this case, what is the independent variable? What is the independent variable? That's my question. And while you guys are typing up that answer and thinking about that, I'm gonna make example 4. Nice. And you know what? I hate to say it, but man, I'm running out of time quick. We're going to have to run through this stuff quicker because I got to get to the next part of this lecture, which I have to do in like 15 minutes. Woo! This is where Mr. Daldick goes quick. All right. Let's run through the rest of these. Cool? All right. Here we go. In this thing, the independent variable is whatever the cure he was trying to test. The dependent variable is the smell of his shell, because the smell of his shell depends on the cure, right? What should SpongeBob's conclusion be? Well, see, the thing is, he screwed up the experiment, so he can't necessarily say that it was Dr. Kelp that gave him a better it gave him a better smelling shell, or if it was seaweed that worked. So he screwed up the experiment. Even though the result that he wanted ended up happening, he wanted the smell to smell better, and that would be fine. He just screwed it up. So when you answer a question like that, I want you folks to type that out. Like, I'm going to give that to you in an essay question. You guys need to be like, well, he's actually screwed up doing the experiment, because what he should have done is he should have rubbed the seaweed for a week, or maybe he should have rubbed half of Gary's shell with seaweed and half of Gary's shell with Dr. Kelp, or maybe a third of Gary's shell with seaweed, a third of Gary's shell with Dr. Kelp, and a third of it he didn't do anything with it. And at least then, the one that he doesn't do anything with, he has a control. He can see how much or what it smells like if nothing was done to it. Yeah, then you can compare. That would probably be the best thing to do. But SpongeBob is kind of an idiot. He screwed up the experiment, as he usually does. All right, here we go. Whoa, you cannot see that at all. Anyway, let's do this one. Microwave Miracle Patrick believes the fish that eat food exposed to microwaves will become smarter and would be able to swim through a maze faster. He decides to perform an experiment by placing fish food in a microwave for 20 seconds. He has a fish swim to the maze and records the time it takes for each thing to do the maze. After he feeds the food, special food to 10 fish and gives regular food to 10 others. After 1 week, he has the fish swim through a maze again and records the time. What is Microwave Miracle Patrick's hypothesis? His hypothesis is if I feed microwave food to fish, they will become smarter. That's an if-then statement. Which fish are the control group? Well, the control group is the one that doesn't have anything specially done to their food. And in this case, the special thing means microwaving it. So this is the group of fish that only received regular food. That's your control. Which is the independent variable? The independent variable is the microwaving of the food. The dependent variable is the time it takes for the time it takes for a fish to finish a maze. Man, that was a tongue twister. It's the time it takes for a fish to finish its maze. And in this case, it's actually trying to measure how smart a fish got, but you can't really measure how smart a fish got. So maybe they figured that, well, the ability to run a maze means you're smarter. And if you're a complete idiot, you can't get your way through a maze. Okay, all right, fine. And that the time that it takes you to run a maze depends on how, it depends on what you call it. Depends on how much microwave food you eat, according to this person's hypothesis. All right, look at the chart and see what your results are. I cannot see that to save my life. So let me look at this over here. There we go. All right, so this is the specialty microwave food, and they went down to a minute 20 seconds, 157, 220. Oh man. All right, I'll tell you what. Oh wait. Here's what we look at. We look at the before and after. So what we'll have to do is take the mean of this, and then take the mean of this, and then maybe subtract them. Versus taking the mean of this and taking the mean of this and then subtracting them. And then whichever one has the smaller or the better time range you can conclude will have that's who you can say did a better job. No, you cannot go now. I mean, I know that I said I would finish early, but at least let me go till 11:15, which is when I told you we would finish. I mean, sheesh. You only want I only want Mr. Dalton to talk for 10 minutes. Okay, moving on. I'll tell you what, I hate to do this to you, but we need to. I'm going to open up this next thing. We're going to play a game. It's called Jeopardy. Well, it's actually not Jeopardy. It's basically just a bunch of questions that Mr. Dalton is asking you. Here's what you need to do. Let's do this, and we'll do this. I want you folks to open up this website. I'm going to text it over to you. All right, here. I'm going to spam it. Open that website up. Tell me if it works. Okay. I'm spamming it some more. All right, good. Not everyone needs to tell me it works. I just need a few of them. All right, I want you to open this up. I want you to have two tabs. I want you to be able to switch back and forth between the class tab and also this this website that I'm opening up. So split it up into two tabs. We're going to kind of play a game. Oops, I screwed that up. All right, there we go. So we're going to talk about this. In today's lesson, I'm basically going to teach you by asking you a bunch of questions. The website that I gave you should have all the answers that you need. Got it? Are you ready to play? Why do humans need water Jeopardy? I have a question, by the way, and it's just, I know it's only going to take up a second of my time, but man, I don't have a whole lot of time these days. Here's my question is, did Lay start drinking water out of the back of a toilet yet? Did you guys get to that part of the book? Okay. All right. No? Yes? No? I don't know. Did she start drinking water out of the toilet? Whoa! I guess she didn't do that at that point in the book. Well, I think you guys are going to get to that point. Have fun. All right. Anyway, yes, she starts drinking water out of the toilet. Well, let's see why she needs to drink water out of the toilet in the first place. Spoiler alert. Yeah, Mr. Dalday screwed that one up for you. Actually, I did that on purpose because we need to talk about, what we're going to be doing. All right, anyway. Question 1. What is the chemical formula for water? I just want to know if you know this one, actually. There we go. You folks already got it. It is H to the O. This means 1 oxygen and 2 hydrogens. That's why it's the H with the 2 on the bottom. Hydrogen, and an oxygen. Very good. I think that it would be Titus who got that answer correct first. And what's nice is I can see who typed it in first. All right. What percent of water is salt, fresh, and frozen? Give me the 3 different percentages. What percentage of water is salt, fresh, and frozen? It's in your handout. It's in that one website that I showed you. Or at least I think it is. You can Google it. Go for it. There we go. 97% is salt water. Yes. 2% of it is frozen. And did you get how much fresh? The fresh water is 1%. Very good, Titus. Again, man, you're killing it here. Exactly. All right. Basically, all of the water on Earth, 97% of that water is salt water. And salt water can almost like not be used at all. We can't cook with it. We can't clean with it. It's junk. 97% of the water we have, that kind of sucks. 2% of the water on Earth is frozen, and 1% of the water on Earth is what we use to actually drink. So all the water we drink is made up of 1% of all the water that's on Earth. Is actual usable fresh water. Yeah. Crazy, huh? All right, next question. What percentage of our body is water? Okay. There we go. I believe it's Chelsea this time who has the correct answer. Now, Chelsea, you got that answer from the website I gave you, or from the what you call it? Did you get it from the website I gave you? I just kind of knew that. Okay. I think it says on the website that I gave you that it's exactly 70%. Even though the answer I wrote down here was 60 to 70%. 80% is a lot. I mean, if you're 80%, I'm thinking you're kind of watery. 90% water, that is like you're basically Aquaman at that point, or a mermaid, maybe. All right. But 70% water is what the human body is made up of. All right. One medical source that I've read documents men having 60% of water and women having 50% water. So men are just a bunch of hot water at that point, huh? All right. What percentage of blood is water? So we're talking about the blood specifically. Aha, Ethan's speed is living up to his name. Very good, Ethan. It is 80%. I screwed up this typing up over here. It's 80% of your blood is made of water. All right. We've got like 10 more minutes. Let's keep talking about this stuff. Slide 14. Here's a bonus question, but I'm not going to have you do the bonus question. Can you identify two main functions of water in the body's metabolic process? I'll identify up to 4 other bodily functions that water has for 1 bonus point each. I'll tell you what, you can Google this if you can't find it anywhere in your thing. Because I'll be honest with you, you probably won't find it. All right, digesting, oxygen. Okay, good. P, actually, all of those answers is exactly right. Here, let me show you my answer page. Water has 2 main functions in the metabolic process. The first is to deliver oxygen and other nutrients to different parts of the body. That would be what Jonathan said. And then Titus and Seamus both said digesting and pee. What water does is it removes toxins in the form of pee and poop and sweat from the body. That's what water does for you. It is important. Kind of important. It's made up of 70% of your body is made up of it. Water has other functions as well. It helps you regulate your body temperature. How does it do that? through sweating. Of course, humans don't sweat, we perspire, so through perspiration. It reduces friction between the joints and helps you move. So if you want to be able to do like a backflip or something like that, and you need to be flexible, you better be drinking water. If not, you're going to have like arthritis style things. You know what I mean? It acts as a cushion between organs in order to protect them. It basically kind of acts as your own little personal airbag, which I think is why why I'm so fat. It's because I got a lot of water acting in between my organs to protect them when I fall. Because Mr. Balde's a clumsy guy, and it facilitates normal functions of the body process. And I think that would be more like peeing and pooping, and I think that's what the nice way that they're saying. And then I think, let me see, is Gabriel drinking water right in front of us? There we go, Gabriel. You're getting your joints up and frictioned. You're also adding cushion to your stuff so that when you fall down, you can... That is an awesome wall, by the way, behind you. That's crazy cool. All right, moving on. What are 3 different ways that the body loses water? How much water does the body lose in one day from normal activity? How many days can you survive without water, and how much water loss could cause death? All right, I've got a lot of people peeing right now. I've got Gabriel saying 3. You're talking about, what, 3 days to survive without water? Okay. How much water would you lose if you're going to die? %. If you lose all of your water, you'll die. Chelsea says 12. Okay, all right. 12 is kind of small. Joshua says 12 as well. Maybe you folks are reading inside of that one packet that I gave you. How much water does the body lose during normal... Okay, I'll tell you what. Why don't we look at the answers at this point because we're running out of time. A person can go without food for several weeks if necessary, but without water, it cannot last more than a few days. A few often meaning 3. The human body is 60 to 70% water. You take in water from food and drink, but you lose it through peeing, sweat, and breathing, actually. Breathing is actually a major part of your water loss. Crazy, huh? You don't want to lose water, stop peeing and sweating and breathing. All right. A person loses 2 to 3 quarts of water every day as a result of their normal body functions. 2 to 3 quarts. That's 1.89 to 2.83 liters. That's like a 2-liter soda. That's crazy. That's more than it. I mean, on average, that would be a 2-liter soda bottle. That's a lot of water. Anyway, this much loss means that if a person doesn't get any water or fluids for 3 days, they will die. 6 to 9 quarts of water loss would cause death, or 12% of the person's water composition. If they lost 12%, as Chelsea pointed out, then they would die. So if you end up peeing one day, if one day you end up peeing like 6 liters of water out, you'll die. Although I'm sure that at that point you'll, know to stop peeing. Maybe there's something that would cause you to lose that much water. I don't know. Whatever. Yes. Stop peeing. Everyone stop peeing. That's good for you. No, that's not. That's not. You need to drink lots of water so you can pee a lot. All right, here we go. How much water does the average person lose in one day from urine, sweat, and normal breathing? I told you that urine, sweat, and normal breathing is some of the ways they lose water, but how much water is that? All right. Give me a second. I got a call from UH. Hello? Hello? Hi, Dr. Lam. Can I call you back? I'm actually teaching a class today. Can I call you back? Yes, you should be getting that today, actually. I'm going to be hand delivering it. All right. Aloha. All right. I'm sorry. What did you say? 3 minutes? What? What? 800 milliliters, 20%? I'll tell you what. You don't know the answer. I'll tell you right now. On an average, in one day, an average person loses between 2 to 3 quarts of water through urine, sweat, and normal breathing process. If a person doesn't replace the lost water, then dehydration begins to occur. At 1 to 2% dehydration, you get thirsty. So when you're thirsty, you're actually already 2% dehydrated. At 5% dehydration, a person becomes hot and tired, and their strength and endurance decrease. At 10% dehydration, they become delirious. They become crazy, like I don't know, crazy, and they get blurred vision, and they become a problem, and you can't move. At 12% to 20% dehydration, a person dies. Sorry, Gabriel, you died prematurely. You were supposed to die at 12%, not 10%. At 10%, you're supposed to go crazy and stop moving. No, you died already. Man, come on. If you're going to act it out, stay with me here. Anyway, all right. Very good. I'm glad you're participating. Let's move on. So, this is the graph of it. Cool? So, and actually, I think that's the end of the questions. I think, I'll be honest with you, I didn't keep score, but I remember Seamus, and I remember Titus and Chelsea answering a lot of questions. So I also remember Joshua and Juan answering a lot of questions, and Kylie and Gabriel. And pretty much everyone did it. So let's give a hand for everybody. Everybody else give a hand for everybody else. There we go. Thumbs up and clapping. Awesome. Eric, I remember you. Yeah. Monica, I remember you answering. Yeah, good. Okay, so let me conclude this lesson with this. Most people have never thought about the above because they've never been personally confronted with extended shortage of fresh, safe drinking water at any times in their lives. In many other countries, they think about this every day. A shortage of fresh, safe drinking water is a daily problem. Here's how much water you lose during competition, says Master Chief. If you're a lightweight boxer, you lose water at a rate of 0.85 quarts per hour. I think the craziest one for me is the tennis player, who loses way more than someone running a marathon. Almost 6 times more, or 5 times more than the person running a marathon. So, Ethan Speed, Joshua Knight, you better start drinking lots and lots of water. Because apparently, you're losing water at 5.92 quarts per hour, and a person running a marathon is losing water at 1.51 quarts per hour. And this is kind of crazy to me, too. It's sorry, Gabriel, that's really distracting. Do you think you can put that thing down? All right. This is crazy to me, too, is the shot putter loses water at 1.27 quarts per hour, whereas the 200-meter sprinter loses water at 1.19. Isn't the shot putter guy just throwing a big cannonball? That's what he does? He just spins around and throws a ball? How is he losing more water at a faster rate than the person sprinting? I don't get. I don't understand. But anyway, that's what the numbers gave me, so I'm just giving you the thing. It looks crazy to me. Sounds like something that would be fun to test, though. All right. Keep in mind that these numbers only represent what the human body needs on the inside. We haven't even talked about washing your hands or brushing your teeth or bathing. Also needs for water. All right. Other water facts that I want to go over with you, and I have no time at all. I gotta go. I gotta end class. Lou, I'm coming down now. I'm ending class. All right. Well, I accidentally ended the class faster than I thought, but sorry. GTG. Bye. Right, here we go. Stop the recording.